Okay, yes, so I'm an astrophysicist and I like to get high, but before you jump to any conclusions, it's of course getting high on mountains, on telescopes like the Keck Observatory or the Very Large Telescope in Chile, or the flying telescope SOFIA that I want to talk about today. And even though we feel closer to the stars when we're up there and observing, that's not actually the reason why we build telescopes up there. So something is light years away, it doesn't really make a difference if you get a kilometer or two closer. So the actual reason is that our Earth's atmosphere is not as transparent as it seems to us in the optical. There are wavelengths that are completely opaque from the ground. One example is UV light, which is absorbed in the ozone layer, as most of you know, which is cool for humankind because we can go to the beach without being fried. But if you're a UV astronomer, you really have to get high, which is a solution there. So UV astronomers build balloons, build space telescopes because they have to get above the ozone layer. And in the infrared, which is another really interesting part of the optical spectrum, to do studies of planetary formation, to do studies of exoplanets, which I'm doing, study molecules that are interesting for astrobiology. In the infrared, it's not the ozone. In the infrared, it's the water that absorbs most of the radiation. And there are some parts of the infrared spectrum that you can't, that's completely opaque from the ground. But luckily, most of the water in the atmosphere is not as high up as the ozone. So most of the water, 99%, is really bound in the lowest part of the atmosphere. So as soon as you get up to, let's say, 12, 15 kilometers, slightly higher than commercial airplanes, you're completely above all of water, and that whole window of infrared opens up to you at that height. And that's actually where the SOFIA comes in play. So SOFIA is a joint project between NASA and the German Space Agency. And it stands for Stratospheric Observatory for Infrared Astronomy. So we fly up in the stratosphere and do infrared astronomy. And it's like snakes on the plane, but it's a telescope on the plane. So it's really a 16-ton, 2.5 dish in the back of the Boeing 747. And you have a big garage door that opens. And then that telescope is exposed to the outer shell. There's some walls between the cavity, obviously, and the observers on board. But in principle, we are flying up there. It's like a space mission almost. And that's the key, actually, for SOFIA. If you take a telescope like Hubble, if you want to update it with the latest instrumentation, you have to send up really costly and dangerous missions with the space shuttle, with astronauts. But with SOFIA, you basically have a space telescope that comes home every morning. So you can really put the newest, latest, fanciest instruments on board on SOFIA. And I flew on SOFIA 3 times, or to stay in context, I got high on SOFIA a couple of times, and it was really like the highlight of my career so far. And yeah, maybe next time you have a red-eye flight and can't sleep on the plane, you might want to open the shade and enjoy the view in the infrared light. Thanks.